All right, welcome back to another conference presentation re-recording. So this time I am re-recording the presentation I gave at the first ever VISAGE Visual Effects Creative Festival in Nairobi, Kenya, and it was held on the 5th of April. So huge shout out also to the VISAGE team, Yvonne and Rugi and Philip and all of the rest of the team, and thanks for having me as a presenter. So let's dive into the slides, and as always, I'm just re-recording everything as if you'd be sitting in the audience right there in Nairobi, Kenya. Let's dive in. Sweet. So the presentation today is about the art and technology behind digital film environments. What we are seeing here is a shot that we actually developed together, a visual effects shot that we developed together with Equator Arts, who is basically the running force behind the Visage visual effects creative festival. And so this was done in collaboration specifically with Yvonne about 3 years ago, maybe a little bit more. So the foreground we actually did as a 3D environment, actually up to approximately here, and then the rest, and that's Yvonne's core expertise, was basically a matte painting, filling in also the city. Now, because back then, a couple of years ago, we didn't have super high quality 3D buildings and not yet enough to kind of do a shot like this fully CG. Now, this one here is another shot that was produced exactly at the same time in the same setup, where Yvonne also helped us with basically the matte painting, filling in a lot of the background distance buildings. And in the foreground here you see the Equator Arts logo also. Here also Yvonne helped with augmenting our geometries that we had back then a little bit more with grunge and kind of decal projections done all in matte painting. All right, the agenda. So in the presentation we are going to talk about film and visual effects, architecture and environments, storytelling, a word on AI, because why not, right? And then we're going to talk about quickly talk about the learnings before we're diving into the outro and quick Q&A, which we're not going to do today because it's not the actual event. All right, quick intro. So my name is Matthias BUEHLER and I have a background in architecture, and I'm the founder and CTO of Urban. Now, at the moment, we are 13 people. Soon we will be 15. And my first steps in 3D graphics in general were approximately 1992. And so then now since about 15 years, I've been specializing more and more in, especially in procedural, so-called procedural urban 3D modeling. Now, as a part of this is that I'm a City Engine specialist. City Engine is a 3D tool that can be used for very efficiently creating very large-scale 3D environments, especially cities. And we are going to dive into this in a few minutes, what it is and what it can do. Now, I'm also a Gnomon workshop instructor. That was a couple of years back already, actually, where I created a training DVD for the Gnomon workshop. And also, that's where I actually met Yvonne. Between 2015 and 2016, I was back in the day working at Scanline Visual Effects in Vancouver, working on some large-scale environment systems, integrating City Engine actually in the Scanline pipeline, and that's how we met and started to collaborate. Now, so as a company, uh, what are we doing as Urban? So we specialize in 3D architecture and environments specifically. Um, so we are built, or we have the structure of the company is actually two business units. One of them is Urban Solutions, the other one is Urban Studios. Just a couple of examples here. It's a couple of years old already, meanwhile, but still super proud work. We're super proud of this work where we created over 500 3D buildings for this PC game called Transport Fever 2. And the buildings were actually created in three, let's say, ages. Or three time stamps that you can play in the game. Then another project that is kind of that started already a few years ago and is still ongoing to this day is collaboration or basically technical support and services that we're providing to the city of Zurich, the city administration, in multiple aspects, from actual city planning or urban planning technologies, and also creating these procedural systems and building typologies as we see them, for example, here. But also with this specific twist that the data is actually usable for historic reconstructions. So on the left hand, you see the different geographic data layers that they're maintaining. And then extended to that is the 3D functionality, where, for example, vegetation is made as kind of 3D billboard geometry is very lightweight for the web, and then the specific 3D buildings. Also, we helped a bit with the kind of the creation of these fictional, not fictional actually, historic satellite pictures, how this is made, and so then when everything comes together, you have this digital twin that also contains basically historic buildings, and multiple timestamps are actually created or basically between the year, let's say, 1800, 1400, back to 5,000 years ago, which was actually kind of the historic settlement, which were one of the very first projects we did together with the city of Zurich. So very, very interesting work. Now then, taking some of this open data, which is actually created and published by the city of Zurich, so this is open and freely available GIS data. We developed a small in-house render workflow that helps us also to produce some larger scale 3D visualizations. And what we see here is the city of Zurich in Switzerland in the year 1800. Cool. So that was Urban Solutions. Now switching to Urban Studios, what we're doing is we're focusing on developing technologies that help us produce high quality 3D content, which we are selling on the shop. So that's on vrbn.io/shop. And if you go to the shop, it looks something like this, where you see a very simple kind of natural or let's say a preview of the building with just very natural lighting, just a very honest display of what you can actually buy with multiple screenshots. And then this can look something like this. So we have some certain assets that we're producing and selling, like, for example, cranes or containers and these kind of gas containers. But also, or other assets like these ones here, like these Euro pallets, or these kind of, I forgot the name, what these guys here are called, kind of these sign cylinders, whatever it is, right? But then also the specialty, and that's where most of our efforts are going in, is in these realistic buildings that are also optimized for both offline rendering actually and for real-time rendering with all the bells and whistles that are needed to get everything running fluidly in a game engine. So the visualization here is also made like the few of the previous ones, made in the Unreal game engine. Same here, and as you can see, we have to go relatively far so that even the glass the glasses are bent so that the buildings actually look realistic. Then another visualization here, also made in Unreal, is basically a very large scale 3D environment with basically all that you see, with the exception for the trees, is everything is made in-house, and pretty much all of this content is available on our shop. Sweet. So let's talk about the first topic, film and visual effects. So the typical 3D project, whether it is in VFX or in games or in other industries, typically works a little bit like as follows. So you have a design phase, then you're creating certain 3D assets, or you're getting them, you're buying them from different stores. Then by basically assembling them, you're creating the environment. Then you have animation and effects. This can be just camera moves or cars driving around or explosions, all of these things. And then the visualization, which is basically just kind of communicating the story. Diving a little bit deeper into each of the points. So you have artwork definition, specification also of how the design should work, what the kind of poly counts are, how the texture qualities, all of those things. And then specifically also how the whole pipeline of the production should work. Then the assets, obviously you have 3D modeling, texturing, the so-called look development, in kind of fine-tuning the look of each individual asset. Then you have the layout of the whole, let's say, a city or a game level, and that I always believe that the atmosphere is actually part of the layout, because you want to tell a mood, you want to tell emotion of is it rainy, does it snow, and kind of all of those elements, which are like in the natural realm, are just part of the environment. And so the whole thing is basically, the whole environment, you could say, is a container or the container for the whole story that you're telling in your project. Then animation and visual effects, this is where you're actively telling a story by, for example, moving characters or destroying things, or whatever it is, right? Telling your movie story. And then visualization, in the end, you have the rendering aspects and the compositing, kind of taking the image elements and laying them on top of each other to really fine-tune the look and make everything look perfect. And obviously the visualization there, the whole component also of audio comes into play. But let's leave this detail at the side. Now, where urban comes in typically is I would say we are stronger on the side of, let's say, the design, kind of having these discussions about what the design should be, and then both creating the assets and helping with the tools of the layout or of the environment creation. But as you have seen before also, and you see this also on some of the social media images that we are posting, we also do have some knowledge in visualization and kind of the whole image, or let's say storytelling psychology that goes into the storytelling. All right, now moving on to the film production specifically. It's a similar process. So you have, at the beginning, you define the scope of the movie. Then you're going into pre-production, production, post-production, and in the end to the delivery. Now, there are multiple of those charts available if you're searching for them on the interwebs, and you find different structures, different let's say levels of complexities of how the whole process is explained. But we're gonna just stick with this one and keep it at a very simple high level. All right, so the scope of a movie typically starts with just an idea and then a budget, and if everything goes in the right direction, then you have a go to actually start and produce the movie. Then during pre-production, you have the script, you're gonna refine it, you're gonna write the storyboard or come up with the storyboard with little sketches and everything that is needed. Also, obviously, concept art, pre-visualizations, also known as previs, all of those things. Then production is the actual video shoot where you're recording the actors either in front of a green screen or on the movie set, whichever one is needed. And then post-production, there you have multiple aspects of, once you have the recorded footage, that you can, let's say, superimpose computer graphics elements on top of the video footage, or change things, and so on and so on. So there also, for post-production, there's still a lot of design work that needs to go into it. Matte painting, again, Yvonne Mendes' specialty in creating these very beautiful vistas and destruction scenes with rubble and everything, and the moody atmospheres. Obviously also animation and kind of visual effects in general. Now, maybe just a quick word on that. So the word visual effects is typically kind of just mentioned, or basically an industry that is focusing on the post-production. Sure, certain aspects like starting to prepare for being able to work on the visual effects work for post-production, this stuff actually very often also already starts at the pre-production, because, for example, the so-called visual effects supervisor is actually involved very early on with the film director to be able to plan what is actually needed afterwards, a couple of months later in post-production. But then also part of the rest of the post-production is color grading, voiceovers, recording the audio, for example, and also the movie score, the movie soundtrack, and then editing and so on. And last but not least, the deliveries, then formatting into the different codecs and file formats to be delivered to the YouTubes, to the streaming services, and obviously also to the cinemas. Just a small detail, but there's one huge inspiration for me to found Urban was this company, The Third Floor. And what they are doing is actually they are just focusing on previs, which, as you see in the whole film production process, is just basically a tiny part. The Third Floor comes from basically a team of founders that used to work at ILM, that's Industrial Light and Magic, that got very, very famous for their original work for Star Wars and many other movies since. And so basically there were a couple of people that decided together, let's leave ILM and let's build a company specifically just built around previs. And they took a chance, and it took them a long time of really, really hard work. But now they're a super established company, and they're doing some absolutely fantastic work. And just I took this as an inspiration because the pie is so big that I basically decided I would like to do the same thing, just not instead of, or not around previs. I want to create the same thing around the creation of architecture and, in extension to that, larger environments. So yeah, still working on it. It's ambitious, but yeah. All right, let's continue. Cool. So let's talk about architecture and environments, right? So why this specialization in general as a company? So first and foremost, there are a lot of technical challenges, and I like them. I like the little nitty gritty in solving all of those little details, and a little bit also the unorthodox engineering that as I typically name it. And in general, yeah, it is a very, very complicated field to work in, not only architecture, because there's an infinite amount of variation that you have to control, but also because in computer graphics you have a lot of different tools and packages and file formats and just challenges for optimization that are necessary to be able to create these environments. Now, also the whole environment in itself is as we have seen, a container for the story. And so there's a certain skill needed for let's say, for taking an inspiration of a story and actually being able to massage this basically into the environment, into the, let's say, volumetric cloud effects, into the color of the sun, into the architecture and the city layout. So you are actually able to help telling the story through the environment. So there's a lot of psychological elements that also go into this aspect of storytelling. And that's just a dialogue that needs to be had with the people that actually want to create these environments. So I see basically the whole, or architecture in general, or an environment as basically a silent actor that also needs to be basically orchestrated. And I love this dualism of the technical challenges, of bringing everything to life, but still having this kind of silent actor that plays a major role in the story. Let's have a look at an example, and this still frame is from the movie Dread, which was released, I think, around the year 2012 or 2013. One of my all-time favorite movies, because it has such a dense atmosphere, and just in general, it's a fantastic dystopian movie. I love those. And why I'm showing you this image here is that talking about story is really, or thinking about the story that you're trying to tell when creating these, let's say, fictional environments. What are the elements that you need to think about? And for me, one of the most inspiring things is to just consider the thoughts of, let's say, here in the buildings down here, behind these, in the movie called kind of the mega blocks, like these massive towers with about 200 floors or even more sometimes. So what does it mean to live kind of in all of these tiny little buildings where you're kind of in the shade of those mega blocks? So you don't get any sunlight. It's kind of grimy. It's a dirty world that is basically described through the narrative of the movie. And what's actually happening with the architecture? What's happening with society? What does this mean for the infrastructure, for existing buildings, and in general the society that lives there? And you see all of these grungy elements, and yeah, just these incredible kind of volumes that just need to be right for the storytelling. And all of those aspects that I just described are just really important in the sense of planning your environment, planning the urban density, planning the architectural details of, for example, this kind of incredibly large, you could say, so-called brutalistic architecture. And so there's a lot of knowledge which goes into selling the story, and I'm deeply fascinated by all of those aspects. Same thing also obviously here with this haze, with this fog, with this very kind of also dramatic lighting and this dramatic mood that is really just part of the storytelling and needs to be engineered so that we understand how horrible a world like this would be to live in. Now, looking at some, let's say, a real-world tool that is out there called space syntax. You can see it up here, space syntax. You will find this picture and the description also on Wikipedia. So what space syntax is basically a, you could say, a geometric algorithm which can take a set of lines, in this case street center lines, and then based on some parameters, basically compute how important certain streets are, based on kind of where, if they are more in the center of a city, or if they are more kind of in the kind of remote branches of the street network. And one of the most important aspects is also kind of the deviation angle between the different line segments. And so the researchers which have developed this algorithm actually found that based on human perception and human psychology of how we move in the environment as let's say as entities kind of moving from A to B, we actually prefer, let's say, slightly deviating angles between street segments, even if it means that it's a little bit a longer way to go and less direct and less zigzaggy, basically. And so it's super fascinating to see the outcome once you have run this, for example, this space syntax algorithm, that if you look at this kind of false color representation, that so the red colors are the most important streets and the blue colors are on the other spectrum, they are much less important. And if you map this on top of the real world city map, or let's say a satellite picture, you will actually see that the colors actually correspond approximately, or actually very closely, to the number of lanes that you actually have in the real world. So it could be that the blue lines, the blue center lines are maybe just 2 lanes to drive, or even 1 in some cases. But then the red ones, they can be, let's say, 4 lanes in one direction and 4 lanes into the other direction on exactly the same, let's say, avenue, for example, or boulevard. So there's a lot of, let's say, scientific approaches to urban planning and tools that are available that we as creators of environments actually have on our fingertips, or should be able to control, to be able to create fictional environments that are actually realistic and help us to tell the story. Then camera distance and degree of freedom. Now, let's say we are comparing a fixed shot for visual effects, or let's say for a movie that plays in a cinema, versus completely free navigation in a game, or for example in a virtual reality real-time demonstration. So the big difference is the first one, the fixed shot, has a fixed camera movement or camera position where the viewer of the movie cannot interact with that camera. It's just given, right? Because we're sitting in the movie, we are watching the cameras being moved by the director. And if you have something like a game, there you have, or a lot of games, meanwhile, you have completely free navigation. You can roam wherever you want, you can drive wherever you want. And so there's basically a very cool analogy, or a very cool, let's say, little piece of information that I find very fascinating that kind of tells you the difference, is that if for a movie you have exactly, let's say, 24 images per second, multiplied by the length or the duration of the movie, I don't know, 1.5 hours, multiplied by the actual image resolution of the movie. So it used to be full HD, 4K, whatever it is. So if you calculate this over the movie, you have a fixed number of pixels that you have to control for the entire movie. Now with a game, it's basically, because you can freely move wherever you want, you can watch or look into every direction, you basically have an infinite amount of pixels which you have to control. Because of that, obviously, certain tips and tricks or certain hacks that you can do for fixed shots do not apply for free navigation. So you need to manage all of your resources differently. And this is why it's so much harder to have a completely photorealistic looking 3D game versus a completely photorealistically looking movie, because of the following graph that I'm going to show you. So the chart actually says what are the features that you have to build on the vertical axis. On the horizontal axis, the distance from the camera. So let's say you have just a shot that looks at a very large scale environment and just moves slightly over. You can do this perfectly fine with, let's say, just a 2D photo or some matte paintings and maybe 2 or 3 layers or so that are behind or layered behind each other in a kind of a 2.5D projection. And it can look absolutely photorealistic. But then, let's say you want to have certain elements that are a little bit, have more of a 3-dimensional nature. So because maybe there's a rotation in the camera also needed, and you need to, just 2D, 2.5D parallax doesn't work. So you may need to have a couple of cubes somewhere with textures that are projected on them, so that you get a better understanding of a 3-dimensionality of the environment that you're showing. Then you can continue going closer up to the camera because the rest will break otherwise. So you might already need to have a little bit of a rough form of the trees or of the buildings. You may also need to have some 3-dimensional or elements on the top of roofs like chimneys or antennae and so on. And maybe also even some simple reflections in the building when the buildings or the elements are coming closer to the camera, because you can see where it would break, right? But then if you come even closer and closer and closer to the camera, you see there's actually an exponential amount of detail that you just need to be right for the illusion to be correct. It's still fictional, it's digital, but you need to add so much more detail. Like, for example, you need suddenly to have super realistic materials. You need to add dirt and weathering on and stains on the facade. You need to have, I don't know, glowing neon sights that are flickering in the alley and so on, that you would never ever be able to see like 5 miles away in a matte painting, right? And so this is something that is really, really hard or important to understand when you're creating an environment, especially with 3D cities. If the elements are coming closer and closer and closer to your camera, in the kind of worst case, in a game where you can directly walk through an entire city, you need to solve all of the details wherever you can go to exactly the same level of quality. And that's a massive difference for a game, for example, compared to, for example, just let's say an opening shot for a movie, where you just see an environment that is very far away, or kind of, yeah, doesn't have a lot of parallax. All right, let's have an example or look at this example here of the Griffith Observatory in Los Angeles. So if let's assume this were a shot in the movie where you're panning from left to the right, then it's obvious that the building itself, the observatory, would be a so-called hero quality building that would need to be hand modeled perfectly. Also the lawn with this kind of sculpture thingy here, these lampposts, vegetation, and so on and so on. But the rest of the background, maybe this could work with just one photo backplate or basically a painting, or maybe 2 or 3 levels or layers that slightly move against each other to sell the illusion that everything is actually 3D. But there's no need, obviously, to build everything so you can actually see how the back facade is looks of each of those buildings, or kind of I don't know if the traffic lights actually work and all of those aspects, because it's literally not needed for a shot like this. Then also the building typologies, just slightly jumping back, right? So just in this shot, let's go count which types of buildings we have. So we have kind of these residential buildings where multiple families can live. There are some individual buildings. There are some commercial buildings. This could be I don't know, a hospital, whatever. So there are many different types of buildings where people live and work. There's also infrastructure elements that are kind of manifested as architecture. And so if you're looking at the base structure of just two examples of two, let's say, famous types of architecture. So this one here is just basically a commercial building. So this is actually the Candler building, a very famous American kind of mid-rise or skyscraper. And then there's the Parthenon temple of the ancient Greece. And if you're looking at the base structure of how one would create these types of buildings, let's say procedural with certain automation, because you need to create hundreds and hundreds and hundreds of variations of those, you see that the base structure of the step-by-step detailing of these building archetypes works actually completely differently from type to type. And because of this, storytelling of environments needs to address that there are multiple types of buildings to sell the realism. There's not a single city on the planet that has only one type of building, right? And so there, you could say the sky's the limit. You can go as far as you want. You can add many 3D building types, but obviously it's all a question of managing the amount of work that you actually need to put into all of those things. All right, let's have a tiny look at an example of how complex architecture really is. And so it's a simple question. You have one wall and you have one door. So how many ways are there to place this one door in this one wall? And I mean, the answer is pretty clear. It's infinite, right? You could place it on the left, you could place it on the right, you could place it in the middle, a little bit more to the left, a little bit, it doesn't matter, right? So that in itself already proves that architecture has infinite variation. Now imagine, so let's say you're creating a game that has relatively simple visuals with just 3 doors and 5 types of windows. So the amount of variation that you can manually assemble is already daunting, but you can control it, right? You can control it manually with an artist going in and basically just creating the best patterns that are just suitable for this game's look. But if you continue and you say, okay, you want to have something that works in a photorealistic context for a, let's say, a contemporary city, and you don't want to see the same door over and over and over again, it gets much, much, much more complicated. Because what happens if you have 50 doors and 70 types of windows and vents and all other elements? There's no way you can just say, I want to auto-distribute these things, and or without the computer that helps you with the automation to actually truly understand what it is that you have to achieve. And there's a tiny little example here that will make it pretty clear that the whole logic that goes behind these systems needs to be really complicated, because in the real world you will never see an ATM machine on top of a little window, for example. So all of these placement, let's say the metadata of the assets, knowing on top of or to which side of which one can I be, all of these things will need to be handled. And there are multiple methods that are very useful. Obviously, procedural modeling is one of those things, but eventually the complexity gets more and more or bigger and bigger, and you need to find other ways to solve these things. And so kind of just briefly going back to this slide here with all of the different building types, and also with this complexity of just arranging, let's say, windows and doors and all of those things, you see that it's an incredibly complicated topic. And this is why we as a company say, let's just specialize in this, because there are so many storytellers that will not have the time or let's say also the budget to specifically solve all of these problems also for their stories. So let us stick to our core expertise and specialize in this, taking some of the work that we like and other people might not even like to try and solve these things, so we can actually produce better stories, better games, better films eventually, by collaborating and everybody sticking to their core expertise. All right, so just a couple of examples of a system which we have developed for all our 3D buildings that you can find on the shop, that actually help sell the illusion of three-dimensional interiors. So this technology is called parallax occlusion, and we invested heavily in creating our own textures that can be used in this system. And for that, our artists actually created about over 800 individually stylized complete 3D interiors of different types and sizes for the different building types and typologies that we are developing. And then from these base environments, we actually derived lots and lots and lots of texture atlases that actually have the information about this three-dimensionality of the room, plus actually a so-called mid-plane to give you a little bit of parallax within this just material-based 3D interior or kind of fake 3D interior system. So lots of work went into this. It was about 5 to 6 people working for 1.5 years just on this effect. Now in this animation here, you can actually see it, how this works, with also the system managing that some of the blinds are actually closed, some of them are open, as you would have it in the real world. And all of these elements are obviously needed for compressing everything, for optimizing the data, so that the stuff actually works in a game engine in real time. Sweet. So let's have a quick look at this video in City Engine. And so how the system works is you're developing so-called rule sets, which you can assign to the surfaces of a street layout and of the city blocks. And then so that's basically programming a script or programming a rule that understands the modeling of the city fabric. Now, in our case, we are just using our pre-existing or pre-created 3D buildings as an asset or coming from a asset library, but the rest of the environment is actually fully procedurally created, as you see, because everything is updated within a couple of seconds. And so, as I said, this is done entirely in CityEngine, and so the tool is incredibly helpful for us in multiple aspects, but especially also here in the environment creation. So we are developing multiple of those rule sets. One of them is for industrial areas. One of them is for residential areas. The same thing also for commercial areas and downtown, plus obviously the whole cityscape. And we're constantly trying to refine the code and add more details. It's just endless amounts of work that we're doing, but it enables us to, when we're creating one of those city layouts in CityEngine, with the different block subdivision and street widths and all of those aspects, to then be able to select the different areas and assign these different rules to the different, let's say, areas. And what comes out after that is, once CityEngine is done generating all of the preview geometries, is then this entire 3D representation of the environment within CityEngine, as basically as a modeling framework or a modeling tool. And from there we can obviously export it to different tools. Here we see another example, by the way. So the left-hand side are the so-called shapes. That's kind of just a rough layout that is done really fast and really efficiently in CityEngine. And then the right-hand model is just the generated model coming out of these two ingredients, the shapes on the left plus the rules. So we have this representation in 3D. Obviously, still the representation at the right is handled with just low polygon geometries. Otherwise, the software would not be able to manage this really well with kind of high detailed trees and so on. Cool, but yeah, from there, what we actually are going to do, and I just made a little sketch doodle with this area, and we can export this one here. And for example, go to the Unreal engine or Unreal game engine and create these real-time optimized visualizations of the environments. Here's another representation of a larger environment, actually rendered in Houdini with the renderer called Redshift. And you see that, so this is offline rendering. Obviously, you can render very, very, very large data sets where, for example, the amount of textures don't really matter. So that's a slightly different visualization technique as real-time rendering. So you need to optimize less here. But still, it's so impressive to see what can be done or once you have these the rules, once you have a strong library of 3D buildings and other elements, how far you can actually go within a relatively short amount of time. So another couple of examples. So here you see 3 of the skyscrapers that you can get on our shop. And you will also notice that all of these interiors actually have this parallax occlusion effect activated. So you can see, even though that there are no 3D interiors actually in the geometry, or there's no 3D polygons of tables and chairs and lights and all of that stuff, but it's all baked down into these texture atlases, which then are mapped basically by a material that can display this effect and give you this illusion of a three-dimensional nature of these interiors. Then also another example here, more by night in this case, where some of our artists took exactly the same visualization workflow to create this a large scale downtown area, and then added went in and manually added some lights here and there to breathe in a little bit of let's say nightlife. Cool. All right, let's talk about storytelling. This is also an image we made, and it's so simple, but it tells a story, right? It tells a story and is just lets you dive into these worlds. And I love this stuff. Here's another example. Just it's so simple. It's just a couple of commercial buildings and the street after the rain that is still wet and kind of reflecting things, and just some really nice clouds. But yeah, we are telling stories here, right? And another example here is a pretty strong story that is being told here. And yeah, the more of high quality content you actually have available at your fingertips, the more efficient you can become in telling the stories, and you can actually concentrate on the rest of let's say of your project, and again focus on your personal key core expertise. Virtual production. So one of the reasons that we decided some time ago to create all of our content compatible for offline rendering and real-time rendering at the same time was also because the rendering techniques and technologies are kind of slowly to start merging together. And for example, there's this technology called virtual production that you may have seen that got really famous a couple of years ago by the Mandalorian and other movies. And that is really just a strong amalgamation between using on-set kind of real-time game engines, but then also taking, let's say, the camera animation and pushing them back to, so this is production, right? And then pushing, for example, the camera animation and the footage to post-production, where in our case, for example, the real-time buildings could be switched to the highest quality of the buildings for highest quality rendering. So kind of enabling hybrid or so-called hybrid pipelines where real-time production stuff is working together with the high quality offline rendering down the pipe. Yeah, and then so these are the things that we're also doing, kind of storytelling with storyboards in-house when we're producing our own little visuals. So that's actually the story of something that is not yet quite finished, but eventually we'll be able to publish. So there's a kind of a car racing scene racing through one of those cities. So I'm really looking forward to be able to show you this in a couple of days, probably weeks. All right. Then also another aspect of this storytelling is this is back in CityEngine, where the person kind of that designed, or the artist, in this case, the software developer that developed this whole layout here in CityEngine, also was, while actually building the environment for or this specific environment for a helicopter flight, was actually thinking about the flight path of the helicopter. So this is also kind of part of storytelling, and where actually the storytelling is influencing the fictional environment which is being built. So this was fully consciously done in this project. And also this helicopter movie, it's meanwhile actually finished, but I'll show it in a couple of days. Sweet. Then again, storytelling, the whole thing with audio, with video cutting in this case. This is a screenshot of one of our artists working in, for example, in Audition here to cut everything together. And there's a slight sneak peek for that racing animation that I mentioned before. So it's kind of going a little bit in this direction, but yeah, stay tuned. It's going to be amazing. Yeah, storytelling again, another example going kind of in a different direction, but there's we've been collaborating with the Ideal Spaces Working Group. So that's a group of researchers and historians and architects and philosophers working on these concepts of ideal cities and what does it mean to live in a city, for culture, for integrating nature in parks or in as water bodies, and all of those also social aspects. And one of the books that that Uli, the head basically of the Ideal Spaces Working Group, showed me is this absolutely mind-blowing example of the Centre Mondial. That is like a big book with just sketches after sketches after sketches of this ideal world that obviously never was built. And you see kind of that it's an ideal city, so it has symmetries and it's built in this Baroque style. So it would be absolutely impossible to finance a project like this in the real world. But hey, when working in games or movies, why not? Something like this might be feasible, right? Yeah, so thinking about all of those aspects in storytelling and what they would mean for three-dimensional environments is actually something that I just find super fascinating, and is something that I think is just really important to do, and a very interesting discipline. Now, just talking about some concept sketches of a project that we did together with the Ideal Spaces Working Group about creating an actual ideal city. So just showing you some sketches here. This was kind of the final concept art that was made, and you see everything that is black is basically water bodies. So there are these two very massive axes that are going through the city, and then kind of these more, let's say, splotchy areas, that's nature, and then the rest is also kind of the rest is the urban fabric of a city. So it's more meant to be a system of city building, and not necessarily to be taken as a direct interpretation of the visuals of what we're seeing here. So this is a representation where we took this, let's say, mindset or system of how the ideal or how an ideal city could be built, and we then took this into City Engine and started sketching everything as per this system. And this is a preview in City Engine like before. Another detail shot here with a preview of our buildings that we took, and a preview of the water bodies and the vegetation distribution. And then a rendering here done with offline rendering, again done with Houdini and Redshift, and another view here. Yeah, and it's just so fantastic to see what, yeah, the power of storytelling and the power of what would it mean if our society or humankind in general could be living in more sustainable cities, with a lot of green available, with public squares where people can meet and gather together, and yeah, just to with the worlds like that or planned like that, just to be better to live in, as what we have in a lot of places on this planet. Yeah, then another one of those environments that we made some time ago. In this case here, like just a section of an industrial part. And because storytelling is really important, and also you want to be able to drive certain things like the weather or the mood and the whole kind of, yeah, the whole atmosphere in general, because it's so critically important for storytelling. We thought, let's play with this a little bit and let's see how this environment, for example, looks if it's raining or if it's snowing. And especially real-time engines like Unity or Unreal or other game engines make this actually possible in real time. Sweet. And then last but not least, for the inspirations on storytelling and architecture and environments, I can highly recommend kind of really the architecture and environment focused books that are out there, like for example the blueprints for the Harry Potter films or the blueprints for the Star Wars sets. So this can be, or some of them are the actual blueprint for the physical film sets that were built, but obviously there are a lot of art books also available that just show how the digital worlds, the digital realms for the movies and the games and so on were created. So I can highly recommend to get some of those books and get inspired by them. All right, a word on AI. So we are in a very interesting time at the moment where generative AI is becoming quite a scary thing, a scary monster for a lot of creatives. So we are right in the middle of this hype where technology is being pushed by a lot of very big, very strong tech companies, but it's very unclear what the implications on let's say our work are. And I'm definitely a person that also has to really look into these things because it's strategically really important. And yeah, just to see how we can use these technologies for producing better stories, better content without being replaced, right? So I've been looking into this quite a lot lately, or over the last couple of months, just research-wise, and also talking with my own staff and talking to a lot of other people about the topics. And I believe we all agree that AI in general, or especially generative AI, should be a tool or must be just a tool and nothing else. I looked into these things, and just recently I had kind of an epiphany why this is the way that we will most probably go. And so there is, let's say, a certain hope. And I want to share this thought with you. So first of all, we're all, as a society or as a creative, let's say, community, we're all in this together. And we can actually do something positive. Each of us has a voice, and so yeah, we can actually do something by using tools or refusing certain tools, and be just very conscious about these things. But the examples which I think are really strong to me are the following. So Devin Watch was released as a technology, for example, you could say a couple of weeks ago, meanwhile. And it's basically a framework that allows you to get individual AI agents as individual kind of instances of tools that basically mimic being a software developer. And you can get as many of those as you want and basically tell it or give each of those agents individual software development tasks. And then the idea is that they do their thing and they give you the code back and a functional tool. And everything obviously is a commercial framework. And this is obviously very, very scary to software engineers. That's okay, am I going to be replaced? And then just kind of 2 or 3 weeks after this was announced, there was a kind of a push from the open source community that said, hey, now there's an open Devin. So basically kind of just instantly saying, yeah, we acknowledge that there's this commercial aspects of Devin being there as a tool, but we have this free and completely open source version that other people can also work with as kind of a counterweight in against a, you could say, a monopoly, right? And then the second example that I find very, very also inspiring is we all have seen Sora or the videos there, and exactly the same thing happened a couple of weeks after it was announced, or even a couple of months. I'm not perfectly sure about the timing. There is now an initiative called Open Sora, exactly the same thing that is perfectly transparent. And the same thing again here, open data, right? So this gives me hope that the very large community is very aware of those, of let's say the fears or the dangers that a few companies can control everything. And so this balancing act is, for me, or understanding that these are the dynamics helped me tremendously also to, you could say, to sleep a little bit better. And a couple more points on what I picked up from my research, looking into a lot of podcasts on YouTube and presentations and so on. And some of the things that the specialists agree upon are the following. So AI models, so kind of that's the trained core that is used afterwards to create something, they cannot be protected, neither by big companies or by nobody, basically because there's these open source communities that provide their own models that are sometimes even stronger than the original ones that are commercially available. So the models themselves cannot be protected. Coming from this point, or coming from this side, AI models will eventually be a commodity, and hundreds and hundreds and hundreds will be available. So there's this very, very strong, you could say, a democratization of the data, of the training data, and obviously the derived models from that. So what's the real fight about in the end? And it is about compute. And compute means basically the computing power and the hardware. And let's go back. So what we've seen announcements of incredibly large investments to build more and more data centers and supercomputers from, let's say, Microsoft having announced just a couple of weeks back now in 2024 that they want to invest in a new data center, compute center that is worth about $100 billion US. Another couple of weeks back, there was Sam Altman, the CEO of OpenAI, actually announcing that he's fundraising $7 trillion US to basically start developing their own chips, because they want to control the chips and all the infrastructure for all of those things, to also make compute in general, let's say, cheaper, obviously cheaper, faster, and to control that. And at the moment, I would say the biggest competitor, or the biggest player in this field is, or it's very clear, it's NVIDIA, and they have had their stock price has skyrocketed just in the last year, and so everybody wants to have a part of that pie, right? And so kind of, I mean, I'm not in the hardware business most of the creative people are also not in that. So I think the true fight is only going to be about compute. All right. An example of why a tool is just a tool is, for me, this example here. I mean, it's called ParkCAD. It's like a little plugin for AutoCAD, and it's doing a fantastic job in kind of planning standard run-of-the-mill parking for, let's say, suburbs, American suburbs. It helps automate a lot of things, but in the end, it's kind of, yeah, it's just another parking lot, right? It's one of those, you could say, a little bit soulless tools. But yeah, it is a tool, right? But if you're just relying on tools like that, you will never be able to come up with an idea like that. And that's where human ingenuity and human creativity actually comes in and makes a difference. And yeah, sure, this one here is much more expensive, and it's a sculpture, it's a piece of art, but it's the perfect example of why humans still have the upper hand and will hopefully forever have the upper hand on anything that is creative and thus human. Another example that I sometimes also show in presentations, and why human decency is incredibly important in designing real world or fictional environments and architecture, is this example here by the architect called Aravena, and the project is called Elements. It's somewhere in South America. And it's basically a government, you could say, subsidized social housing project, but it's, as you can see, it's kind of incomplete. So there are pieces of this building here, or all of these elements. This is why the project is called Elements. There are certain things that are just missing here. Same also here. There's kind of these pillars where you can build something custom in here. And to me, this is one of a really, really inspiring way of coming from the mindset of the local culture and from the needs of the people that will be living in these houses later on, and truly understanding that they want to interact with their habitat, you could say, with their environment, and not just saying this is the building, it's fixed, it's completely done, and this is how you will live, but actually giving the residents the option to actually change things and switch things and customize things to make it their own. And this is such a beautiful gesture in kind of coming from the government side, but also trying to really understand how people live and what their values are, and how the community, the local community, actually works. Sweet. So let's talk about some learnings. 3D environments and visual effects. Or you could say, yeah, in general, the creative industries. So there are many, many disciplines involved, and especially in the context of the VISAGE Visual Effects Creative Festival, a lot of people coming from different parts of those industries were kind of part of the audience and brought their individual input. So there were students, there were photographers, there were interior architects, there were visual effects people, there were movie directors, there were people that help organize TV series, and so on and so on. So it's much more than just, as we've seen, this tiny bracket of just visual effects in post-production. It's defining the whole value chain. And so there are many disciplines involved in this dialogue. And a lot of the expertise and roles actually overlap and are just really important to work hand in hand and know and understand the role of the person kind of previous in the pipeline, and but also how you format, you structure your output so that it can be taken by the next person. So it's all a team effort. And it's really important for people to understand the big picture of the whole dynamics of the entire industry, but also of your company and what you would really like to do. And so it's the second really important point is about a conscious reflection of one's own role in the bigger picture. So what is that you would like to do? What is that you would like to work on? And what is it that you would like to change yourself? So one of the foundational topics at VISAGE was to inspire change in the creative industries, especially obviously in Kenya. And there are a couple of roles or key player roles which I have identified and I just noted down here. So there are politics or politicians basically, and their role is to understand, shape and strengthen the industries. Then there's education, the teachers. Their role is to understand the industry, develop relevant curricula, and help and discover and foster the individual talents and passions of each of the students. Then there's the industry itself, where it's really important to define and protect the business models that keep the individuals in the center of interest who create the actual creative content. Because if you scare away the people, or if you mistreat the people that actually produce the value, then you don't have a base, right? And then last but not least, all of the individuals themselves. I deeply believe that we should be mindful, we should be humble, and we should be supportive of others. And it's important that you find your true values and goals in life to understand what you want to do for yourself and for society. All right, a couple of personal opinions, a couple of statements. They may be a little bit controversial, but we'll see. All right. So, point number one. In art, everything is about telling a story. Second, art stems from a different place than greed. Number three, money cannot make a bad story better. Number four, a good story may become successful. Writing a story purely for success will cause timeless, lingering fragments of regret. Number five, the best stories touch you in a place you cannot defend. Number 6, creativity needs room to breathe and time to develop. It cannot be rushed. And last but not least, number 7, a company is worth nothing without its staff. And I've had many, many instances in personal meetings with my own staff where I mentioned this directly to them as just a thank you for them to help me realize my vision of urban in general, and to be able to be a creative person, but it's always a giving and a taking. There's always 2 ways, right? All right. Outro. For those people that kind of like these topics around 3D environments in general, just a very quick pitch of my own podcast. It's called the 3D Environment Podcast. You will find it on my personal website, but you can find it also on Simplecast, where it's originally hosted. You can also find it on YouTube and YouTube Music, and also the other platforms like Apple Music and Spotify and so on. All right, this was basically it. Thank you so much for the attention that I got from you, and thank you so much for the whole VISAGE team, the organizers, Yvonne, Phil, and so on, for the opportunity for me to hold this presentation or to give this presentation directly in Nairobi. It's been absolutely fantastic. Thank you so much. And Asante Sana. This has been it. There's no Q&A this time, obviously. And I would say, yeah, thanks for listening in and for your time. Talk to you in the next presentation. Have a good day. Cheers.